Have you ever wondered what the difference is between all the different types of hard lights? I mean, what's a Fresnel? What does that even mean? And what's the difference between a par and an open-faced light? I mean, they look pretty similar. Stick around to find out. Just before we get started, you'll find down in the description a link to a free PDF that breaks down what you're going to learn in today's video. So check that one out and download it as a reference. To get started, let's first define what is a hard light. A hard light, characteristically, is a light source that creates sharp, defined shadows. Relative to the size of the subject, hard lights also have a small point source. The further away that point source is from the subject, the harder the light becomes. In film and video lighting, our hard lights will either have a small bulb or an LED chip, which acts as our point source. To further intensify the output of the light and to provide further control over the beam, manufacturers will add a reflector dish behind the bulb to reflect and funnel all of that light outward in one direction. They may also add a lens element in front of the bulb to further control the directionality, spread, and intensity of the light. The main differences between our different light sources are that open face and par lamps utilize reflector dishes only, whereas Fresnels use a lens in front of the light source to achieve the desired result. Open face lights. The simplest and cheapest form of hard light is what's called an open face light. These lights are designed primarily with raw output in mind and have quite a wide beam angle. The reflector dishes on open face lights are generally pretty average in terms of quality. The reflectors will have a fairly wide spread, allowing these lights to cover a larger area. You can control the spread of light somewhat using the flood and spot function, which will move the reflector dish closer or further away from the bulb, narrowing or widening the beam angle. The reflectors will often have a textured quality to them and are generally spherical in shape rather than parabolic, so the beam won't be particularly even. This will usually result in a fall off in intensity towards the edges of the beam. Due to the lower quality reflector, the shadow quality will typically be pretty average as well. You'll typically get softer shadows and even multiple shadows from the light bouncing around inside the reflector dish. This is not the type of light you would typically want to point directly onto a subject's face or shoot through something like a cucurloris if you need crisp, sharp shadows. The biggest advantages of these types of lights is that they are the least expensive and they give you a lot of output for the money. Open face lights are generally their most useful for filling large diffusers or for bouncing off other surfaces to create large, soft sources. You can also use them as backlights or background lights where you need to cover larger areas. Open face lights almost always come with barn doors included, which are often necessary to control the spill of the light. This is one of the few measures of control that you'll have for this type of fixture. Two common types of open face sources are redheads and Arri lights. Personally, I would also consider most of the standard reflector dishes that are paired with COB style LEDs to fit into this open face category. But this of course varies from reflector to reflector. Pars. The next type of reflector dish is a par, or parabolic aluminized reflector. Pars are a definite improvement to the open face variety of reflector dish. These dishes have been carefully shaped to form a parabolic U shape, as opposed to a spherical shape. This shape will better channel the scattered light beams forward in an even directional beam. The dish is also polished to a mirror-like finish. When the bulb is positioned within the dish, known as the focusing position, this will result in collimated, parallel light beams that have an even beam spread. When the light is defocused by moving the bulb away from the ideal focusing position, the light rays will start to scatter more randomly, resulting in a broader but less even beam spread and softer shadows. Some examples of common par fixtures are par cans, such as par 64s or par 56s. Many HMI lights will also use par reflectors as well, such as Arri Suns and other HMI Cinepar fixtures from various manufacturers. The fabric reflectors in parabolic softboxes also utilize this same principle to create an even spread of light across the surface of the softbox. Convex lenses. Now that we've covered reflector dishes, the next point I want to discuss are lights with optical lenses in front of them, such as convex and Fresnel lenses. Fresnel lenses are closely related to simple plano-convex lenses, so it makes sense to start there first. A simple convex lens is a lens designed to capture scattered rays of light from a single focal point, where the bulb would be positioned, and collimate them into an even directional beam. This is the same principle as a par, except the light is shining through a lens rather than being reflected off a dish. The lenses feature a flat base on one side and a curved spherical front on the other. The light passes through the flat side and is projected out the curved side. The main issue with convex lenses is that they require quite a large amount of glass or plastic to construct them. This lowers the efficiency of the light transferring through the lens, reducing the output, and it also traps a lot of excess heat within the lens itself. This shortens the lifespan of the globe, the lens, and the fixture overall. To combat this issue, the Fresnel lens was then designed, which greatly reduced the amount of raw materials required to build it. Fresnel lenses. The Fresnel lens, pronounced Fresnel, not Fresnel, was invented by French physicist Augustin Jean Fresnel for use in lighthouses. Augustin Jean Fresnel, you must say it like a Frenchman. He designed them in order to reduce the raw materials required to build conventional lenses. Because, as I'm sure you can imagine, a lighthouse requires a pretty bloody big lens. In essence, a Fresnel takes a convex lens and divides up the curved front edge into a series of much smaller segments. These segments are then aligned and sandwiched together along a flat base, forming a much thinner, flatter lens. When viewed from the front, these lenses have a series of concentric rings, each with a different depth and angle of curvature. Optically, Fresnel lenses perform almost identically to convex lenses, but they're much lighter, cooler, and more efficient. Like pars, Fresnel fixtures can be focused and defocused as well by adjusting the flood and spot controls. Of the three light sources that we've looked at, Fresnel fixtures are optically the most superior, giving the sharpest shadows and the most even beam spread. This makes them the best choice for lighting faces and objects, and they're also the best performing when cutting and shaping light with patterns such as those made by a Cucaloris or a cutter. You'll also get the most control over the beam itself, with the ability to create tight beam angles, as tight as 8 degrees on certain fixtures, with minimal spill. The downside to Fresnels is that they won't flood nearly as wide as par or open face lights, so they aren't as useful for filling wider areas. They also have the lowest output per watt of the three, because the light has to pass through an additional lens element. You'll see Fresnel fixtures made by a range of different manufacturers in both tungsten and HMI lights. You'll also find Fresnel attachments for a lot of common LED lights, such as those made by Aputure and Nanlite. In summary, each of these technologies are widely used across various lighting fixtures. Of course, with any tool, each has their own pros and cons. What option would you choose for the work that you do? Let me know down in the comments below. And don't forget that downloadable breakdown, which you can find in the description. For me, if you want good output at a low cost for simple jobs like illuminating large diffusers or lighting large areas, open face lights are your friend. If you're lighting portraits with a hard light source and you want sharper, more defined shadows, or you want to pinpoint and highlight something within your frame with precision, Fresnels are the obvious choice. If you need a good all-rounder that sits somewhere in the middle with a ton of output, pars are the way to go. So there you have it. That's the difference between open face, par, and Fresnel lighting fixtures. If you enjoyed today's video and you learned something, you can let me know by leaving this video a thumbs up. And if you'd like to see more videos on cinematic lighting, make sure to hit subscribe so you don't miss out on future videos. Thanks for watching, guys. I hope you have an absolutely wonderful day, and I look forward to seeing you in the next video.